Alright, so now, energy is the ability to do work. Work is only done if you apply a force on an object. You apply a force on an object. We know what a force is, right? Force. You guys, you told me it's pull or push, but force is an influence that wants to change the state of motion of the object. If the object is not moving, force wants to push the object so that it moves. Okay, so if you apply a force on an object and this object moves across a distance, let's say the object moves, it is displaced, it changes its position. You apply a force, the object moves, then you have done work. Right? If I apply a force on an object like this, I pull it, the object moves, then work has been done. But if I apply a force, the object does not move, there is no work done. I hope that makes sense. If I come pushing this board, the board does not move, there is no work done. I push the wall, I sweat, I go for lunch, come back, I still push the wall. As long as the wall is not moving, there is no work done. Okay, work done is a product of the force, net force, and the displacement. Work done, I hope my camera is catching. Work done is equals to the force times the displacement. What is the unit for work done? Joules. That's what I wanted you guys to know. You are using J. Energy and work done have the same unit, which is joules. Energy and work done have the same unit, which is joules. For work done, the object has to move. If the object was here, it has to move a distance. This distance should be in meters. You apply a force. Let's say, for example, you apply 70 newtons. The object moves 2 meters. The amount of work done will be 70 times 2 meters. You get 140 joules. That's the amount of work that has been done on the object. You have moved this object from here. It is now at that position. You have done work. Is it fine? Makes sense. All right. But when it comes to energy, which is just the ability, sprite, a cane of sprite, then on the side of that sprite they write those energy levels, that if you drink this sprite, let's say this sprite, what's that? Are we in war? Let's say on this sprite, they have written that if you drink this sprite, it has got 140 joules of energy. Okay? Does it mean that sprite is pushing this object from one point to another? Okay, but the sprite has got what? Energy. When you drink it, you'll be able to push this object across the distance. It is just the ability. Ability to do what? To do this. This work done is what you'll be able to do. So energy is only the ability. It is not actually you pushing the object. It is the ability to do the same amount of work that can be done. Another example I can give is that I can ride a bicycle. I know how to ride a bicycle, but I'm not riding the bicycle now. I have the ability to ride a bicycle, which means the ability to ride a bicycle is in me, but I'm not riding the bicycle. If you bring the bicycle, I'll do the riding. I'll do the work done. Same thing, energy, it has the ability to do this amount of work, but the cane of sprite or coke or whatever it is not pushing the object. It's just the ability. Therefore, the unit is joules, the unit for energy is also joules. I hope that settles the dust on those two and why they have the same unit. There are different types of energy. There are different types of energy, a lot of them. Chem, the one we had in our test. What other forms of energy? I've written that. Other forms of energy besides these two. Food energy. Should I write that one? Okay. Sound energy. This is sound energy. When I speak, I am releasing energy. It travels in the air, reaches your eardrums, then you hear my voice. At the end of me talking too much, I'll be tired. I need to go and eat because I've lost energy. There is those that are doing electrical engineering, electrical energy. Electricity comes, it lights up. We have light energy or solar energy if you want. But there are different, a lot of energies, different types of energy. I think these are the only ones I can come up with. Okay. Sound energy, electrical, so on. Okay. There is also heat energy. I almost forgot this. Heat energy. This is the energy that changes the temperature of a substance. If you are heating up something, let's say you're boiling water, water that is cold, when it gains heat energy, the temperature rises, it becomes hot. Okay? This will be a topic on its own. Towards the end of our study, we'll look at heat energy. But all these energies, the unit is joules. Whether it's electrical energy, when you do electrical engineering somewhere in N3 and 4, electrical energy, it will still be in joules. Okay? Chemical energy, those guys that are doing chemical engineering, I'm sure somewhere, somehow, you meet that. Alright, but all energy, the unit is joules. For today, we'll look at this. N5. Electrical engineering, N5A. Does not concern us for now, but we'll do this later on. Heat energy. It's just the energy that makes something hot or something cold. Energy. An object. I saw this in someone's test. Okay. I saw exactly this statement in someone's test paper. I don't know who that is. Energy an object possesses due to its movement or to its motion. Any object that is moving has got kinetic energy, and you'll be calculating kinetic energy is equal to half mass times velocity squared. Now, when they ask you define something, they are not asking for the formula. Okay, let's remember that, because I asked state the law of moments, then someone just wrote that formula. Sum of clockwise is equal to sum of anti-clockwise. Okay, then I got it wrong, because that's not what we were requested to do. So when they ask you state what this is, you are stating that. If they ask also give the formula, that's when you give the formula. I hope that's clear enough. Alright, like we said in our study, the mass should always be in kgs. Always, before we calculate, our mass should be in kgs. Whether it is in tons, you change to kgs. How many kgs is 3 tons? How much? 3,000. Okay, that's fine then. And then your velocity, every time we calculate, make sure your velocity is in meters per second. There has to be movement. Okay, and this is very important because some of the questions they will give us in kilometers per hour, then they ask us calculate the kinetic energy. And don't forget to square that guy. Don't forget to square every time we calculate. All right. Funny enough, that's it about kinetic energy. This one was not there in your test, but I gave the N3 guys. Same thing, energy, an object possesses or has. Due to what? Vertical position above the reference point. Potential energy is the energy an object possesses due to its vertical position above a reference point. An object that is at a certain height. An object that is at a certain height has potential energy. It will be calculated. EP, mass and gravity and the height. They will give you these formulas in your question paper. The only thing you need to know is that your mass, always in kgs, this is gravity, and they will tell you that use 9.8 okay, meters per second squared. Then your height should be in meters, and this height should be a vertical height, straight upwards, vertical, not an incline, but it should be a vertical height at an incline, not at an incline. All right, so suppose we have an object. This object is at the top, the object is 5 kg. The height is 3 meters. This object has got a potential energy, which you'll be calculating using that 3 kg, sorry, not 3, 5 kg times 9.8 times 3, you get your answer in joules. Okay. The amount, that's the amount of energy that it has. Now, this energy depends on the height. The object will be the same, but if we lift this object a little bit higher, even the potential energy will change because we have changed the height. If we lower it a bit, also the potential energy will also reduce. Okay, so potential energy depends on the height. The same thing if I've got an object here in my hand, then I ask the potential energy of this object with regards to this flow. We'll multiply the mass and gravity times the height from here. But then, if we look at it, we have 5 floors from the ground, right? So which means the potential energy of this object all the way to the ground floor is different from when we multiply by just this height. So potential energy depends on the height. Okay, whatever that you got, that's what you shall be doing. But our questions will involve something like this. The object is somewhere there, the distance, let me give it 3 meters. The object is 5 kg steel. This is 90 degrees. If you are given this is the slope length, obviously we cannot use this 3 because this 3 should be a vertical height, and the vertical height is this one. It is not 3 meters. We can see even from my drawing that this is less than 3 meters. Okay, so if you do this, and mostly this is what we'll get, they'll give us the slope length, the incline length. What you should do is get the vertical height. Okay, so this will be wrong. What you do is you use some of your mathematics skills. So katoa. Okay, you use your trig ratios. I hope this guy can get that. Trig ratios. Your trig ratios, you have sine. Okay. Sine theta. Opposite. Hypotenuse. Cos theta. Okay. If you know this, that would be very good. Tan theta. Yeah. Please, if you do not know this, like them and try to memorize them. Okay? Whatever you do, please memorize this. We'll use a lot of this, even in our N3. Just these trig ratios. There are others that you will learn in maths, but for us, you just need these basic ones. Alright. So what you do, trig ratios on this triangle, the longest side, which is the one opposite to your 90 degrees, is the longest side. This will be your hypotenuse, right? Always, the hypotenuse is the longest side of the triangle, and it is always opposite to 90 degrees. Then these others, the opposite, depend on the other angle that you have. The side that touches the angle, this side, will be called your adjacent. It is adjacent to your angle. The other side, which is opposite to the angle that you have, obviously, that will be opposite. Okay. If your angle was not here, your angle was here, then this is not the opposite. This will change and that will change, but the hypotenuse will always be that. If this is your angle, this becomes your adjacent. This becomes your opposite. Always keep that in mind. If you miss that, it's not about you trying to cram this, but just know that that's what you shall be doing. Let's go back to our 20 degrees. This is our adjacent. This is our opposite. And this opposite, that is the height that we need to use here. From our trig ratios, we've got theta, we've got hypotenuse, we need the opposite. What ratio can we use? From these three, okay, sine gives us the angle. It can give us this guy, that's the opposite, that's the one we're interested in, and we have the hypotenuse. Okay, so these others are not necessary. Sine theta, sine 20, is equals to your opposite, our right edge for height, it's our opposite, 3 meters. You cross multiply, right? H is equals to 3 sine 20. Okay, this is sine. Okay, whatever it gives us, that is the value you're using for this. for the height. Now, the more you practice, you won't even need to do all this. You just look at this, then you know that I'm already using sine on that side, the more you practice. But if you're not sure, you can always do this. It's still not a big deal. You're just doing everything with a little bit of caution. So, like I said, we can take now our mass, 5 times 9.8 times 3 sine 20. Okay, I don't know what 3 sine 20 is. Okay, that's why I've just written it like that. So you guys, you can now calculate that's the amount of potential energy. Okay, you guys are doing all the calculations, the funny things. Now, if this object, okay, that's the potential energy, I don't know how much it is, but whatever it is, if this object was, let's say, this object was to fall on this side, it has now started moving, right? It has fallen, it is moving, which means when the object is now at this position, it's no longer having the same height, which means it has lost potential energy. The object finally reaches the ground, all the potential energy is gone because there's no longer a height. Okay? But as this movement was taking place, what is actually happening is that the object is now moving. It now has what? Kinetic energy. Okay? So we can say if we lose potential energy, we are gaining kinetic energy. Alright, so what you guys are saying is the law of conservation of energy, which we know we have been singing this from grade 5. Write that statement. Energy cannot be created or destroyed. Yeah, just for the sake of those ones that skipped class in grade 5, I'll write energy cannot be created or destroyed, but can only be converted or transformed from one form to another. Alright? We can only convert energy from one form to another. You cannot destroy energy, you cannot create energy. You can only convert it or transform it from one form to another. All those forms of energy I wrote down. Heat energy. If you want to heat up something at home, you use electricity, then you convert it to heat energy. You heat up something. You're already converting from electrical energy to heat energy. If we need light, we use electrical energy, we convert it to light energy or whatever that energy is. We're just converting. Okay? All those instruments that convert one form of energy to the other, just for interest's sake, those are called transducers. If you're doing electrical engineering with me, we have that topic in there. A transducer is a device that converts energy from one form to another. A light bulb is a transducer. A stove is a transducer. A microphone is a transducer. Anything that can convert from one form to the other, that's a transducer. Okay, but that's for another day. Now, when in your exam, when they say state the law of conservation, please be very careful that you read clearly. If there is heat there, then it is not this. Heat is something else which we shall do when we look at heat. Is it fine? So when you read the statement, please be very careful. They can bring this conservation of energy under heat questions. It does not mean you have to always state conservation of heat energy. It is something different from this. Okay, so just be very careful on the law of conservation. You only have two: law of conservation of heat energy or law of conservation of energy. Therefore, all this potential energy, how much did we get here? Is that correct? It's not 3 decimals. Okay, it's fine. Please keep in mind, for my test, for the exam, if it is more than 3 decimals, round it off to 3 decimals, not 2. I was marking some calculations with only 2 decimals, but it's fine. For your next test, if it is more than 3, round them to 3 decimal places. If it's just 2, then you leave them as they are. Alright, so what we are saying is that if it has this amount of potential energy, 50.47 joules, by the time this object strikes the ground, this object will have a kinetic energy that is equals to the potential energy. It will hit the ground with 50.47, but as a kinetic energy. The question will be, at what velocity does it hit the ground? At what velocity does it hit the ground? You know that the kinetic energy is equal to the potential energy, and your kinetic energy is that formula. What you are solving for is the velocity. This kinetic energy is the same one as this one. The object is still 5 kg. We have not lost any of the object. What you are solving for is the velocity, and again, your mathematics skills come to play. Depends on how good your maths is. EK is equals to half mass V squared. You can throw everything in there if you want, or you can change the subject of the formula, whichever suits you. Which one would you do? Change the subject or throw everything in there? Okay, yeah, let's throw everything there. Our energy is 50.47. Half the mass is 5 times V squared. Half of 5 is how much? 2.5 V squared. You cancel those. 5. Okay, this divides into that, your V squared. Okay, V squared is equals to 50.47, 2.5. My calculator is being used by the phone, so I do not meters per second. I don't have a calculator. 4, I hope that's correct. Please confirm before you write.